Hey, my name is Anthony, and I've been doing stuff with AI for the past couple of months. I've just created a neural network that can classify images of hands making rock, paper, and scissors using transfer learning and image processing. But first, how does AI process images? Let's say you have a grayscale image that's 6 by 6 pixels. Each pixel value has a value from 0, which is black, to 255, which is white. In a convolutional layer, there is another grid of numbers called the kernel or filter. The kernel's value is multiplied over a certain area on the picture, like so. This filter goes through all the values in the picture. If the kernel goes over an area where there are no values, such as the border of the picture, zero padding is usually added like so. The application of the kernel will result in convoluted images, which we can then apply max pooling. This will decrease the size of the image. In max pooling, we take a grid of a certain size, 2 by 2 in this example, and find the value that is highest in the grid on that image. Stride is the number of pixels to move the grid to the right. The downsampled image can then be used in a convolutional neural network, CNN, to classify images. In color images, the image is split into 3 color channels, red, green, and blue, RGB. Each channel is filtered using a kernel and max pooled, and can be used for image classifying in the same way grayscale images can be used. But there are some things we need to worry about when training our CNN. Overfitting. Overfitting is when the neural network starts to memorize data rather than learn it. This can result in a very bad neural network that doesn't perform well on the test data. So to increase the accuracy on the test data, we can take measures to prevent overfitting. One of them is early stopping, which is stopping training early such that the model is accurate but not overfitting and memorizing data. Another is dropout, which is turning off neurons randomly in the model to increase the training of other neurons. And finally, data or image augmentation, which is artificially boosting the amount of training data by augmenting it. In images, we can apply random rotations, flips, zooms, and movement to increase the amount of images used in training. Now, on to transfer learning. In transfer learning, we can take pre-trained neural network models made by professionals and use them to do our own tasks. I'll take an example of AlexNet. AlexNet was created for ImageNet's large-scale visual recognition challenge. It revolutionized the image recognition world and popularized CNN-based image classifiers. It would be super useful to use these extremely efficient models for our own projects. Fortunately, we can. However, ImageNet and other models that place well in the competition contain thousands or even millions of parameters. While the large number of parameters allows the model to learn more complex patterns and achieve higher accuracy, this makes the model take extremely long to train and requires an extreme amount of computing power. And because I don't have a computer from the gods, I will be discussing the use of MobileNet made by Google. It uses a very efficient neural network architecture that minimizes the amount of memory and computational resources, but does not compromise a high level of accuracy. This makes MobileNet ideal to use on mobile devices that have limited memory and computational resources. MobileNet was also trained on an ImageNet dataset, which makes it perfect for classifying images. With transfer learning, you can get extremely high accuracies on your model without having an extremely beefy computer. This makes transfer learning perfect for people who are just experimenting, or want to use an extremely accurate model but don't have the time to train it. If you want to see the full code, I've linked my Colab notebook in the description. Thanks for watching!